Well, okay. Hey, well, welcome everybody. It is 2 hours UTC, and it's time again for Astronomy Daily Live. So welcome everybody. This is a daily live stream, practically every single day, where just a growing group of friends get together every single day. It's like a circle of friends, maybe like a virtual porch, and we all grab our consumables of choice and sit back and think and talk all things astronomy for at least a little while or so. And I'm noticing that Tom just came onto the panel. Hey there, Tom.
Hey, how you doing tonight?
Everything's good. Everything's good. Just still a little bit cold here, but yeah, that's the one thing about the cold here is that it doesn't last. So for sure. Yeah, so hope everybody's doing well out there in the universe and the world. I'm gonna look at the chat here, at least open it up and see what's going on. So Uncle Bill is there in the chat. I'm gonna look at my weather too, since Uncle Bill did. Let's see what it looks like here. Might be getting some rain, maybe some SNOW, maybe. So don't know exactly. Probably not. Probably not. So yeah, hope everybody's doing well. If you can hear in the background a little bit, I'm playing today's music from the Hearts of Space show. It was all about space guitars. This is actually a notable episode. I mean, all of them are really, really great, but this is sort of like a milestone. This is the episode 1200. So they have 1,200 unique shows now, and Hearts of Space is really, really, really cool. If you like space music, ambient, even what do they call it? Ethnic or cultural sounds. This is a really, really, really great resource. They've been doing this. I think they started local in like the Bay Area in the early 80s, and I think they went national in like 1983, 1985, and that's when I first heard them. Was back then, and they usually went out on like the public radio stations. You know, of course, I was into space and astronomy and all that, so space music was like, wow, just absolutely incredible. So yeah, the Hearts of Space you can subscribe to. There are different levels of subscription. You can just join the website too. And if you do that, then every Sunday, the current week's show is free. So what I do, and actually what I've always done by some means or another, is I just record it. Now that's probably not exactly legal. I'm not exactly sure. I mean, it's not as if I'm selling it or those kinds of things. So I don't think it's a big deal, but I like to record it because then I can listen to it whenever I want to. And if I want to listen to something again, right, that's also a possibility. So yeah, definitely check it out for sure. So cheers to ambient space music.
I hadn't heard of this band until you and Bobby mentioned it.
Yeah, it's you know, when I was working up at the 61-inch up on Mount Bigelow, north of Tucson, it was a situation where I sort of had to be sitting out in the dome with the instrument and computers and everything, and actually running things, you know, from the dome. They had a warm room, control room, and all that, but the instrumentation I had required me to be, you know, basically outside in the cold, and so what I would do is I would turn on music from the Hearts of Space, and you know, the acoustics inside of a dome is fabulous, right? Especially if you can sit at sort of, you know, the focal point of the sound. It's really, really, really awesome. and so yeah, I found myself in as close to heaven as I could possibly be. You know, sitting there watching the photons coming in and thinking about space and listening to just this far out sound, right? That just took me away. So absolutely great. So yeah, definitely, if you like that kind of stuff, check it out. And you know, like I said, you can subscribe. I think the full package, you have access to all the shows that they've ever done. Like I said, you know, they've got 1,200 unique shows now, but oftentimes I would say maybe once a month, maybe 1 week out of 4 or 5, they do a repeat show, right? So they'll bring an old show back and play it again, and so you know, I think if you count up the number of weeks since 1983 or 1985, it's something like, you know, 1,400 or 1,500. I'm not exactly sure, but yeah, there are now, and definitely congratulations. I'm going to have to tweet them. Congratulations on their 1,200th show. Now, it was a few years ago when they passed their 1,000th show, and that was a pretty big deal too. So yeah, you know, it's always nice to sort of, you know, get up to and then pass these stages, right? And you know, who knows where this is going, how long it's going to last. You know, everybody's getting older. It's the same 2 guys doing it. They're both named Steven. One is Stephen Hill. He's the producer. And oh no, I'm forgetting the main guy, Steve. I forget his last name now. But yeah, it's the 2 Steves, and they do it all, and it's absolutely amazing. So, you know, when one or both of those either, well, can't anymore, you know, for whatever reason, really don't know what's going to happen to this, because, you know, there are other ambient music shows now, and media for that has expanded, right? I mean, back in the day, right, back in the mid 80s, right, there was one medium, and that was radio. That was it, right? But now, with the internet, right, there's a lot of possibilities. So, you know, there are a lot of other ambient shows, and I definitely encourage you to check them all out. In fact, I just found one today that I was listening to, and I wonder if I can. I don't even remember what it was called now. Let's see. Maybe I can look back in my history really quick and see if I can find it really quick here, because I was listening to.
That's a live show thing you're looking for?
No, I don't think any of these are live.
Oh, so a show was just a session or something?
Yeah, it's just, just like this one. It's just a bunch of recordings that they put together in a show. Yeah, so actually the one I was listening to earlier today was called Radio Mystic, radiomystic.com. And nice stuff, so if you like that kind of stuff, it's it's sort of like and Tom, you'll like this, it's sort of like space jazz, right? It's really really nice. So anyway, that's what's playing in the background. If it's too loud or too soft, especially too loud, somebody let me know, because I definitely don't want to be drowning out either me or anyone. So yeah, let me know if it's.
So far, it's okay.
Yeah, good. And I know the audio isn't great and the video isn't great, but that's what we have. So what I wanted to do first, yesterday I started showing this star field in my chart, and I was gonna show you how those two things match up, and I started looking at it, and it's like, not seeing it right. So the pressure was on, and there was a massive cosmic failure. But I looked at it again, and so I want to show you, because I think that being able to star hop and being able to find patterns and be able to in your head, right, rotate and flip and all that kind of stuff. I think that is a skill that isn't just useful for science and astronomy and all that, but for lots of things, right? What it does, doing those kinds of exercises, I think, allows you to look at other things in many different ways and roll it around in your head and look at it and all that. So this is just kind of a neat way to exercise those brain patterns to allow you to do that. So I'm going to share my screen, and I'm going to show you this first.
It's always good to exercise your brain.
I actually I definitely agree with that. I also think that it's really important to rest your brain, right? Try to just have as few thoughts as possible. I've actually done meditation for long time, and it's all about quieting the mind. So I think all those things, that entire spectrum is really nice. So here they are again. Okay, here they are again, and so this time I'm just going to point it out. So I was basically right. I just had things sort of flipped around a little bit, and I'm going to make sure that, yeah, okay. So this bright guy here is the purple guy here, right? And this one here is this one here. But then, as you can see, do you see these two little ones here? There's a faint one here and a fainter one here. Well, there they are, right there, right? That one and that one. And so if you draw a line, right, it goes right to this bright guy, which is this one. And then it sort of, you know, almost goes in a straight line over to here. And that's sort of what we're seeing there, right? I mean, it bends a little bit, and that's exactly what we're seeing. And then this little guy down here is this one. And I think we're actually seeing this faint one here too, right? So yeah, there's all kinds of rotations and flips and everything that you have to do. There's a supposedly, right, there's a bright star just off of the field over here that I missed, and there, well, yeah, I don't think that that's a star at all. I think that's probably my CCD camera. So anyway, there it is. It's, yeah, you know, you have to do some mental gymnastics to be able to follow that a little bit. But yeah, you know, so this is sort of, you know, what I'm seeing at the telescope, but it's never pointed exactly at that, right? I think actually when I first pointed the telescope at a particular right ascension and declination, I was going for this one, but I actually ended up on this one. But I could see this pattern, and it's like, okay, I need to move that away, right? And so I did, right? Carefully moved that away, and eventually got to this field of view. Now, it just so happens that all 4 of these bright stars are actually 4 of my 38 targets, which is nice. So you know, now I sort of know that once I actually go, you know, to collect the science data on this, I'll be able to get all 4 stars at the same time, right? So I don't have to do it 1 at a time. I can do it 4 at a time. And all these stars in here that are red, right, are my target stars. These are all the stars in this field, right? That, and I think it's a 1 degree radius. And then this whole thing is actually a 2 degree radius. But so I just have this sort of centered on a particular right ascension and declination, and then a 1 degree radius around that. I found all the stars that were 11th magnitude or brighter, and those are the ones that are in red. Now the purple ones are just the 4 brightest ones, and those were the ones that I was actually going for first. And this little box here, this is my field of view. So you can see that, you know, if you sort of draw this box down here, and then do, you know, the appropriate mental rotations and flips and all that kind of stuff, you can see, you know, that all 4 of those will actually fit. And there's actually probably going to be at least a few opportunities for that. You know, maybe these 3 I'll be able to fit into 1 field. These 2 I can. These 2 I can. So yeah, there are actually 38 colored dots here. So yeah, I think so. Anyway, I just wanted to follow up on that because yeah, I think I sort of left everybody floating there a little bit, going, you know, does he actually have this or not? And yeah, I do. I've got it. So yeah, so that's just an ongoing thing. I need to, now it's basically, I just sort of have to wait for the moon to get out of the way, which is going to be another, 10 days or so. I think it's close to first quarter now. So, you know, in about 1 more week, we'll have full moon, at which time, you know, the moon is rising when the sun sets. So I'm going to have to wait a few more days after that to at least allow for a little bit of time for the moon, you know, to not be up while I'm doing this. So yeah, I'm probably going to have to wait at least another 10, 11, or 12 days or so before I can consider doing any science. I've got to have a dark sky, right? And that's why I don't want the moon around, is because the moon brightens the sky, and it's constantly changing. So I don't want to have to deal with that. Now I probably could, and maybe I will, right? Give it a try, see how bad it is. Maybe it's not quite as bad as what I think it's going to be, especially for these bright stars, right? This star, as I recall, in fact, we can look. That star is magnitude 8.27. It's this last one way down here. So the brightest one in here is a magnitude 6.89. That's that one. Yeah, but the purple one here, that dude right there, is magnitude 8.27. At least according to Gaia. I'm sort of comparing all my photometric measurements to Gaia. So yeah, all right. Well, that's that. I guess the other thing that I wanted to do really quick was actually show some results. Now these are preliminary results, but these are the numbers that I've got so far. So this is actually data that I took last. This data here I took last August, and this data here I took last May. But you know, I've been looking at all this stuff because I haven't. Well, up until a couple weeks ago, I wasn't exactly sure what I was seeing in terms of the results, but now I'm pretty confident in at least what I'm seeing, and I'm relatively pleased with what I'm seeing in terms of these numbers. So these first ones here, like this one, oh, is that gonna highlight? Yeah, it's just being slow. So this one, and this one, and this one. What I've actually done is I've taken a number of images and I've stacked them, right? So I've taken a bunch of, I think these are all 2-second images, and at least in the case of 7243 here, I actually took 200 images, right? So 200 2-second images that I have stacked, and then made my measurements that way. And I'm making 2 measurements, right? I'm measuring the positions of all the stars in the field, and I'm measuring the brightnesses, the magnitudes, and then I'm comparing the positions and brightnesses to Gaia, right? I'm assuming that Gaia is correct, all right? So my goal is to make all these numbers as small as we possibly can. And I gotta say, for the most part, these aren't too bad, right? So my pixel scale, right? And actually we can go back to this image, right? So 1 pixel here, okay? Oh, this thing likes to blur stuff. there a way to fix that? I think there is. I'm not going to mess with it now, but you can see the pixels there, right? One pixel there is almost 1 arc second on the sky, right? It's like 0.93 arc seconds or so on the sky. Okay, so I can't really expect to be able to measure positions much better than about a pixel or so, or maybe half a pixel at best. And that's sort of what I'm seeing, right? 0.77 arc seconds, 0.43, 1.19. Not quite sure what's going on here. I'm going to have to look at the data and actually see. Maybe the seeing got a little bit worse, right? These two data sets were collected on the same night. So, in one case, the astrometry was actually really, really good. And then later on, it was, well, relatively speaking, not too great. But I'm still pretty pleased with these numbers, right? Can't complain about that. And so I did exactly the same thing with the photometry, right? I compared my measurements to Gaia, and I'm seeing differences in the, tens of millimagnitudes. So that's what, 0.061 magnitudes, right? Or 0.037 magnitudes. And then, a little bit of error bar too there. So I'm pretty happy with those numbers though. So these rows, I just wanted to do a comparison, right? So I took just one image, right? Not stacked or anything, just a single 2-second image. And I did exactly the same thing, right? Exactly the same thing. I measured the positions, I measured the brightnesses. And as you can see, for the most part, all these numbers are, slightly larger than these ones, right? That makes sense, except for this right there. So something's going on here. Like I said, my initial guess is that the seeing kind of went bad there. But yeah, I'm going to have to take sort of a look at this and see what's going on. Make sure there's nothing that I've done wrong inside of my code, because that's always a possibility. When it comes to humans, we always like to mess things up. So I'm good at that. So yeah, these numbers here correspond to the number of stars that were used in the measurement, in the position measurement, and then this is the number of stars that was used in the photometric measurement. So as you can see, I don't have a huge sample here in terms of photometry, right? So that's why I'm doing this, because instead of having there's like 6 plus 4 plus 8, so there's 18 stars here, right? So I can look at these numbers and I can be really happy with these numbers, right? But am I confident that those are correct? Well, with a sample of 18 stars, I'm pretty confident, but I would like to be a lot more, right? So these, of course, correspond to the number of stars that are magnitude 11 or brighter. So that's why I have now all of these guys, right? so I can sort of fill in that gap, right? There are 38 of them here, right? So if I have, what, 18 plus 38, oh, I should be able to do that in my head, but I'm not going to. So that's 56 stars, right? If I have a sample of 56 stars and I'm still seeing these kinds of numbers, I'm going to be really, really confident. I'm going to be really, really happy with that. I'm pretty happy now, you know, sort of at least enough to you know, I'm be able to move forward, and you know, keep this project going. So yeah. Now the task is to just get more stars, and sort of see what I can do, you know, to sort of push this, right? Because I mean, you know, I can see down to like 11th magnitude here, 12th magnitude. These numbers basically sort of double. So, you know, that's getting into an area where it's like, oh, that's not all that great. So I think at the moment I'm sort of going to be stuck with a limiting magnitude of 11 in terms of getting, you know, really, really good photometry. I think the astrometry is basically going to stay about the same. So and that's not bad, right? So, and I can probably go much fainter with those. So yeah, you know, these numbers are all preliminary, definitely subject to change, but you all are seeing this first. So no one in the universe is seeing this except me and now you. So for what it's worth, there you go.
I don't know what to say, Cosmic.
Well, hopefully these numbers are going to stand up and not, you know, hopefully I'm not going to find something, you know, terribly wrong, you know, some kind of awful, you know, oversight or mistake or something. It's like, oh man, no, it's totally wrong. But you know, this project started back in March, right? So March, April, May, June, July, August, September, October, November, December. This has been nine months to make this table. So you know, I've you know, looked at this really, really hard. There's always a possibility, you know, that I've made some kind of mistake. I'm using Gaia because they don't use any filters either, right? So you know, most of the other surveys use some kind of filter, right? And so since I'm not filtered, I would have to do some kind of translation between my system and theirs, which can be done. But I like the Gaia data because it's completely wide open, right? And so it really is a valid comparison. And like I said, I'm really happy with these numbers, right? Really, really happy. Anything less than 100 is okay, is a-okay. And some of these are pretty small. Now, can they be smaller? Yeah, I think so. Looking into that. So we'll see how all that goes. All right. Let's see. I'm going to stop sharing for a moment. Like that. I'm going to check the chat really, really quick. Hey there, Ray. Nice to see you in the chat. All right. Well, so Cheers. Look at that. I haven't drunk any of this. Ah, it's bad. All right, well, cool. Well, I hope everybody saw the Rocket Lab launch. Looks like it was a success. I guess they did deploy as well. So yeah, I think that was a complete success, which is extremely awesome. Don't remember exactly what they were deploying. It was a some kind of NASA thing. Is that right?
They were sending up 13 CubeSats. Some of them were for governments, and some of them were for some education institutions. They didn't really go into detail about what was in each one, but some kind of experiments from some schools.
Cool. Yeah. Nice. Yeah. So it's extremely awesome, to see all these things going on now, and hopefully there will be more. It looks like, I think this is this Rocket Lab's, I think it's their second commercial mission, and I think their third successful orbital mission. Does that sound right? I think so.
Yeah, I don't know. I know they haven't had too many so far.
Yeah. So absolutely fantastic. I think that's great. The only I guess my only gripe, right, is that during the launch, they had a camera on the rocket looking down, and I don't know if it was somehow got some kind of debris on the lens or something, or what it looked like, it was just terribly out of focus, just like really bad. So that was kind of a bummer. Probably it was some kind of debris, right? Kind of shot up on the lens and messed everything up. So, and I would guess that they would sort of set the focus on those things, and they can't change them, or somebody wasn't paying attention or something. But that's a extremely minor complaint. So those cameras, actually I would think that those cameras, in terms of doing engineering and all that kind of stuff, that kind of data is probably really useful to those folks. But yeah, I don't think that they're going to get much out of that one, because it was pretty terrible looking. So
I don't know how any of those cameras survive all that shaking and the heat and whatever else is going on.
Yeah. But I think it's great, right? It's such a fantastic view. When I was a kid, I went through a period of time where, I did the model rocket thing, right? The SD's rockets, and one of the rockets that they had that was just completely out of my price range, just totally out. It had a camera on it, right? So, these rockets were such that the engines would have the nozzle and the fuel, and then when that burned through, right at the top, there was another sort of explosive thing that would pop out a parachute, right, and then it'd come down. Well, that parachute popping thing could also trip a camera, and so one of the rockets that they had was actually a camera, and when I saw that, it's like, yeah, that would be very cool, to see that. So, to be able to see this not only you know, just a still shot, but you know, a live video, right? That is absolutely fantastic. And actually, some of my favorite videos are all videos of all time. They put cameras on the solid rocket boosters of the space shuttle, and they not only had video, but they had audio. So there are lots of recordings of the rocket booster separation, right? And then the whole way down, right? You got video and sound all the way down, you know, to splashdown, and you can hear, you know, the water sloshing and all that kind of stuff. So it's really, really, really cool. And so, yeah, I'm really, really glad they do it. I totally agree. It's you know, those things have to be either really well protected and or really, really, really tough. Although I think protection is probably the most important thing. But yeah, I'm sure glad they do that, because that is just fantastic, you know, because it really feels as though, you know, you're right there. In fact, I think probably one of the best videos that I've ever seen recently was Blue Origin's recent one. Oh, what, 6 months ago or so, when they launched their sort of manned capsule, and I think they had a mannequin in there, right? Some kind of a dude there, and they had the camera, you know, trained on the mannequin and looking out the window, and you know, I mean, that just allowed me to be right there, and to really get a sense of at least what it would look like, right? I still, you know, I have a hard time imagining what that would feel like. You know, that's a lot of G's, and then all of a sudden 0 G's, and then a lot of G's again. Yeah, I don't know. I don't know how that would actually feel, but the view, right? The view is absolutely stupendous. Yeah, and so yeah, I really, really like those. And like I said, Rocket Lab did it again, and I think they've got it down really, really well. And you know, if they're deploying CubeSats and stuff, then you know, they have customers, and off they go. It's fantastic. So so yeah, really, really, really exciting times for sure. So all right, well, cheers to Rocket Lab.
I've always liked the way SpaceX did their cameras, and they seem to be getting better at it too on their launches.
Yeah, and I think I don't know how involved Ben is from TMRO, but he's very, very clearly involved in that video effort. I don't know if he's in charge. I don't know, you know, if he's making all the decisions about those things, but he is definitely involved. And you know, of course, I don't know him, but just from the show. But you know, he seems to be, you know, really on top of things, and you know, really, really wanting to make things really, really, really great. So yeah, I totally agree, Tom. SpaceX has sort of led that way in terms of quality. So yeah, and they're doing well. There's a test of the manned capsule for SpaceX coming up in January. Is that right? I think so. I don't remember what the details are. Do you know anything about that?
Yeah, it looks like Dragon Demo 1. It's either the 17th or 18th of January. It says 8 p.m. Eastern time on the 17th, but that's, it's pretty far out for that. But yeah, it looks like they're going to do a test, a uncrewed flight to the International Space Station.
Okay, so they're actually going to send the capsule to the space station.
Yeah. Yep.
Cool. Nice. Yeah. I think that's all going to go really, really well. They seem to really be on top of things, know what they're doing, and it isn't easy. I mean, at least I don't think so. Yeah, and it'll be nice to have, a second means of getting people, there and back. Right now, we have one means of doing that, and that's Soyuz, which is absolutely fantastic. Gave us a little bit of a scare, right, a couple months ago. But very reliable, works well, but it's probably pretty expensive, and there's still this nationalistic thing, right? It's like we poor Americans are having to rely on the Russians, to get us up to the space station, and the Americans, I guess, just don't really like that all that much. Being an American myself, I think let's just get up there. I just like to have more than one option.
Yeah, and if it takes cooperation with somebody else, let's do it. There's no reason we can't. Everybody's trying to do the same thing, so working together has got to be better than everybody trying it themselves.
That's exactly true. It's a synergy thing, right? And I mean, it'd be so much better working together on these things. We will eventually, but we humans are pretty stubborn, so that's how it goes. Like I always say, if we don't destroy ourselves first, we're going to do some really, really, really amazing things. I mean, we're sort of right there at the cusp of starting to see some really, really amazing stuff happening. We just have to hang on a little bit longer, and then we can get on with things, and sort of forget about all this ridiculous, fighting and secrecy, and they can't know what we're doing, although we're doing exactly the same thing, and yeah, it's just it's starting to get well, to me at least, pretty silly. So hopefully more people will start to see things that way too, and try to figure out ways to sort of end this, right? I mean, I want to know what the Chinese are doing, right? They send a mission to the far side of the moon. Haven't heard a word, right? Have you ever heard anything, Tom, about that?
Not too much, just that everything worked on their flight there. I haven't heard much about what they're doing since they got there.
So you've heard that they actually landed?
No.
Oh, okay.
And I don't think they were going to be landing until next year, till sometime in January. I thought they were going to do surveillance and do some, studying
Oh.
the whole backside there and figure out where to land.
Oh, okay. Okay.
I don't think the landing was going to happen right away.
Oh, okay. Okay. Yeah. I guess in my head, they were just going to go there and land. So that actually, I guess, makes a little bit of sense, right? That they, because of course they probably don't have access to the lunar reconnaissance, orbiter data. So if they did, they probably wouldn't have to survey again. But yeah, I guess that makes sense, right? They're going to have to check out some spots and see where to touch down. But good. Well, so what you have heard though is that they got there, right? Is that right?
That's right. Everything seems to have worked from the launch and the arrival and all that.
Cool. Very, very cool. Yeah, that's a pretty exciting project there, right? Because landing on the far side, right, means that you have no direct means of communication, right? So what they're doing, of course, is they're I guess they're going to be using a satellite as some sort of a relay thing, right? So the lander is going to send their information over to the relay, and then the relay is going to beam it back to Earth. So very, very cool. Now that has been done before, like on Mars, right? We're doing that on Mars right now. But still, that's a complicated task. But yeah, with the far side, that is the only way to do it, right? So very, very cool. I hope that they are completely successful with everything they're doing. I think it's absolutely great. It sort of looks like the Chinese are going to be walking on the moon sometime soon. Again, we have absolutely no idea because we don't talk to one another. So, but that sort of looks like where they're going with that. Now, why they're doing this, who knows, right? Who knows? Definitely, we need to be, doing the exploration thing and the science thing and all that. But they probably have other plans too. If they want to set up a moon base or something, they want to see what kind of resources are there. On and on and on. So really, really great, really awesome stuff. I just wish that we could cooperate a little bit more and be going with them, because what an incredible adventure, right? All right, well, look at this. We've talked about photometry and astrometry and rocketry for 53 minutes now, and we haven't talked anything about galaxies or stars or anything else. Let's do that for a little while. Let's go back to Corvus. Let me make sure that I've got it. I think I pulled that up here. Where is it? Did I? I did. And in fact, I think what I want to do instead is go back to Burnham's, because I think, that's volume 3. It'll be in volume 3. It's in volume 2. And go here because Burnham's did list a few binary stars or multiple stars as they call them, and they did list some variable stars too. So I'm just going to look. Here's the Burnham's list of double and multiple stars. I've shown this already, but I'll show it to you again. That's all these guys here. Let's just see. Now, I think we looked at Delta core yesterday, and that's actually listed here. Yeah, 24.2 arc second separation. Let's see, magnitude. The bright one is magnitude 3, and the faint one is magnitude 8.5. So let's see if there's any. I don't really see if there's any other interesting binaries that Burnham's lists. So let's go on to the variable stars. So these are the variable stars here that Burnham's shows. So you can see R and U and V and X. You know, the variable stars have these kind of weird names. It looks like a lot of them are what are called long period variable stars, right? So they have periods of like 317 days and 283 days and 225 days, right? Some of these are shorter, like 0.74 days and 0.31 days, and that's because these are binary systems where one component is actually passing in front of the other, right? So just like we're doing with finding transiting planets, we can basically do exactly the same thing with stars, but these are usually much more noticeable variations in brightness, and you can sort of see that here too. So, for instance, this one, and why don't we look at this one in a little bit more depth? Okay, here's RV core, and it looks like its brightest is 8.4, and its faintest, what is 9.2? Yeah, 9.2. It's upside down on my screen, so that's why I'm not seeing it right. But I'm kind of curious to see if we know anything more about RV core here. It's an eclipsing binary, but what kind? There's a bunch of different kinds. So let's take a quick look and see if Simbad has anything about that. Simbad has information about practically every star in the sky. It's pretty amazing. It's a great repository. Which one am I going for? This one. Okay, so let's go over to Simbad. Over here, and we're going to look for RV, and I think it's Corvi is how it's CORVI. Eclipsing binary of the Beta Lyra type. Okay, Beta Lyra type. I don't remember exactly what that means. We can find that out too. Beta Lyrae variable. So Beta Lyra, of course, is a star in the constellation of Lyra, and let's see. Man, I'd like to have a picture. Let's just do this, I guess. So Beta Lyra, do we have a, oh, of course we don't have a, oh, okay, well this is a complicated system anyway. Look at how many components there are. So, kind of complicated. I don't know if that's typical. Let's see. So, the light curves, and let me try to zoom in here a little bit. Can I do that? Yeah. So the light curves for Beta Lyrae variables are quite smooth. Eclipses start and end gradually. Quantity is so large that that it envelops the whole system in a common atmosphere. Wow. The amplitude of the brightness variations is usually less than 1 magnitude, the largest being 2.3. Periods are regular. Okay, cool. Kind of cool. Oh, I'm going to zoom back out here. Oh. I'd like to get a light curve, though. I wonder if AAVSO would have light curves. Let's see if we can. Well, let's do it this way instead. Let's look for a light curve. I'd like to see one. I wonder if any of these are. Oh, okay, so this is actually from AAVSO itself. That's kind of nice. Take a look here. Here we go. So this phase, right, is just usually goes from 0 to 1, right? So 0 is sort of the beginning point, and 1 is the end. For some reason, they've sort of decided to plot this in a different way. So it goes from 0 to 0.8 of a phase, and then you come back over here and pick up the rest, right? So pretty cool. It looks like this is the V magnitude here. So yeah, Beta Lyrae at least goes from what, about magnitude 3.4 down to about 4.4 at its faintest, and then yeah, it's got this typical deep curve here, and then a shallower curve here, right? This deep curve is when the fainter, usually smaller companion, I guess, to the primary star passes in front of the primary star. And then this curve, or this dip here, is when the primary star passes in front of the secondary star. So you have this double curve thing. All right, well, cool. I'm not gonna get too far into that because I want to stick with RV Corvor. So let's Corvus. Let's actually see if, I wonder if we can. Well, let's try this. Go over to AAVSO here, and let's look in Corvus. Maybe I'll zoom in again here for you. So here I can choose a constellation. I'm going to go down to Corvus, like that, and let's see. We'll just look at just the variables, right? Just the confirmed variables. Let's order it by name, so it's easy to find. And let's go. So these are all the variable stars in Corvus. Now you remember Burnham's listed, and I'm actually going to count them here. There's 9, right? So Burnham's listed 9. Look at them all now. These are all the known variable stars in that little tiny constellation. Is this crazy or what? Look at all that. goes on and on and on. Oh, there's our V core right there. But you can see there's just tons and tons and tons. Now, as you can see also, right, I mean, a lot of these are like super faint, right, 18th magnitude. So, you know, that's you know, digging down pretty deep. But let's look at RV core. RV core right there. So I'm going to zoom out a little bit so we can see the whole thing again. Oh, maybe a little bit too much. Here we go. So this just gives you the basic information. Position in the sky, right? The right ascension, declination. I think this is the type of variable star. So we'll have to look that up. Here's the period, right? So when we're looking at this thing, right? So from, where is it? So from here to here is 0.7472 days. So let's just put that into a little bit more reasonable numbers. Multiply that by the number of hours. So almost 18 hours, right? Almost 18-hour period. So actually pretty darn fast, right? I mean, we're talking stars here, right? Not you know, even a well, let's see. I'm trying to think. Are there any solar system bodies that have that kind of an orbital period? Io, right, has an orbital period of like something like 16 hours or 18 hours or something like that. But you know, that's a little moon going around. You know, I mean, a big planet, but I mean, relatively speaking, you know, sort of a little planet. These are two stars going around each other in that amount of time. So that's pretty extraordinary. But then what we can do is we can actually click on this and get more info. Tons and tons and tons of info. Let's see, including, you know, things like proper motion, other kinds of names. We're going to have to come, well, here, can we find out? Okay, so an EB is a Beta Lyra type. That makes sense. Expand this a little bit. Ellipsoidal components and light curves for which it's possible to specify the exact times of onset and end of eclipses because of a continuous change in the system's apparent combined brightness. Yep, secondary minimum. And then a KE is a contact system. So this is very, very cool, right? These are two stars that are basically in contact with one another. So, you know, going around one another, but they're also touching. So pretty cool. Pretty cool. I could, let's see, you know, I'm looking at this and, well, that's for that one. Let's see if they actually have some light curves here. Because, see, I mean, it's going from 8.6 to 9.16, so that's about 1/2 of a magnitude. I should be able to see that in my system too, so that's kind of cool, and it's pretty bright. Let's see if there's any light curves or anything like that. You know, got to admit, I haven't used this site enough to really know. There's an ephemeris. I think that's just going to tell us, which is nice. It actually tells us when mid-eclipse is, right? So that's kind of cool. That's pretty cool. So yeah, you know, they show it for the next month or so. It looks like. Not seeing any light curves. I don't know. References, external links, catalog data, images, click retrieve images to download and view. Well, let's take a look here, see what this does. I have absolutely no idea what it's going to do. It didn't seem to do anything. Just brought me back up to the top. Oh, there it is. Okay. Okay, so yeah, this is just a image of the star, which yeah, it's still the star. But yeah, I'm not seeing any light curves. Maybe we have to go elsewhere for that. As I said, I haven't used this catalog. Let's see if I can. Yeah, we can actually get back to here. I guess I'm not seeing. Maybe we have to go all the way back. I'll have to check this out a little bit and see if we can actually get some data from this. I might have to be logged in. I don't think I have a login account or anything like that. So yeah, it might not be possible. It's a plot. Doesn't. I think that's probably just like a chart or something. Yeah, it's just sort of showing. It's kind of not quite sure what that is. So yeah, we'll have to check this out a little bit more, see if I can actually find some light curves. But for what it's worth, let's go back down to this dude. Oh, did I miss it? I did. RV core. Yeah, see, it says that there's 4,737 observations here. So, yeah, should be somewhere. I'll have to take a look. I'll have to poke around a little bit more, see if we can find anything. Bob Nelson's O-C files. I don't know what that. Oh, that's a spreadsheet. Yeah, okay, which I've just downloaded. Well, let's take a look. I've got LibreOffice on this machine, which is quite nice. Although sometimes it takes a while for it to come up here. Let's see if it does. And then, wow, look at the time. Amazing. Uh-oh. You may choose to wait a short while for it to continue, or force the application to quit entirely. There we go.
Did you break it?
Eh. Don't think so. Where did it go, though? Oh, I think I probably did. All right, well, that's how it goes. Let's try that one more time. I'm gonna, you gotta be stubborn about these things sometimes. Gotta be stubborn and persistent. Okay, yeah, it killed everything I was doing here, so I will try to recover it. Well, is it doing it? I don't know. Not a happy computer. It's poor thing. I make it work awfully hard. Yeah, okay. I'm not going to be able to interpret this. right away. So yeah, I'll poke around a little bit, see if I can. Oh, now there's two. I'll see if I can find some light curves here. So, all right, let me get back to that. And yeah, wow, it is 3:15 UTC. So yeah, I think it's about time to get out of here for now. So let's do that. Yeah, let's get out of here. So, well, have a great evening, a great day. Make sure to subscribe if you haven't. Spread the word about this. This is sort of what we do every single day, practically every single day. Just as a reminder, the live stream for the 22nd of December is canceled. I've got a solstice celebration to go to with some friends, and so I'm just not going to be here. So you know, we light a fire and, you know, just sit around and look at the sun and look at the stars, and that's about it. But it's always a lot of fun, and it's the solstice, so you know, that's always a good reason to celebrate, I think. So that'll be going on, at least in terms of UTC, that'll be going on the 22nd. So yeah, there won't be a live stream that day. I think that's just in a few more days, 4 or 5 days or so. But otherwise, we're here every day, just casual fun, looking through astronomical things. You know, trying to find out a few things, learn a few things, just, you know, having a great old time. So come on in whenever you want. You don't have to come every day, but if you like to, you are extremely welcome to come in. And yeah, I think that's it for now. So I'm going to get out of here. I'm going to go crash and burn, and I will see you in a little less than one spin of this little tiny planet of ours. So, all right, well, take care, everybody, and I will see you then. All right, bye.
Bye.